Hello guys, so I'm gonna solve homework 6, the plotting, okay? Because again, many of you has just messed up with it. So it's good to do that before the exam tomorrow. Okay, so to broaden your, thinking how to solve such problems. But fortunately, many of you has got it right, almost right. So the only problem with the solutions that I got is that you assumed the ideal voltage model. Although I said before that when I when I didn't mention anything, use the constant voltage model. Use the ideal voltage model only if it's explicitly in the question say use the ideal voltage model. Okay, so the default is the constant voltage model. So let's see how to do that. Okay, how to solve this problem basically. So we have here a diode and in series with a battery, okay, and the battery has a negative voltage minus 20, and the input is just 110 RMS, okay, so the maximum is 155.5, the minimum is minus 155.5, and it's 60 hertz, okay, and all that stuff, sine wave. Okay, so the best thing to do here, okay, is to differentiate or find the input at which the diode will turn on. Okay, this is really a fantastic trick. When you do it, it will make many circuits easy to solve or analyze. Okay, so let's find the input minimum at which the diode will turn on. When the diode turn on, VD is equal to 0.7 and ID is equal to 0. Again, this is the first point uh, in the characteristics, the transition point. Okay, so let's see what's happening in the circuit at that point. So basically, you will have here a current ID equal to 0. Okay, and here we have a 0.7. And this is now the input minimum. Okay, good. So let's make Kirchhoff and see what is the input minimum will look like. So let's go back to the black. The input minimum minus VR minus 0.7 or VD minus VB equal to 0. So the input minimum equal to VR plus 0.7 plus VB. VR is 0 because VR is equal to ID multiplied by R, and at the input minimum, the input at which the diode will turn on, the current is 0. So VR is 0, VD is 0.7, and VB is minus 20. Good, so the input minimum is minus 19.3 volt. Okay, so this will be the transition point. And what I mean by that, when V input, so we have two cases. When V input less than V input minimum, the diode is off, ID is equal to 0, VR is equal to 0, which is required to be sketched or plotted in that question. And if we apply here Kirchhoff, okay, you will see that VO plus VR equal to VN. VO plus VR equal to VN. VR is 0, so VO is equal to VN. Actually, VO is equal to VD plus VB. But, stick to the question. The question is asking to draw or plot VO. Number 2. When V input larger than V input minimum, the diode will turn on. So VD is equal to 0.7. And if we look here in the circuit, VO is equal to VD plus VB, and VD is 0.7 now. So VO equal to VD plus VB VO is equal to 0.7 minus 20, so VO equal to constant minus 19.3. So let's apply Kirchhoff to find VR now. So Vn equal to VR plus VO. Go back to the loop, you will find that is correct. So VR equal to Vn minus VO, which is minus 19.3. So V input plus 19.3. This is VR. Good. Now, some of you has got that right. I mean, made the analysis right. But when it comes to plotting, they just messed up. Okay, so let's see how to plot such thing. So we need first to, mark the transition point, which is V input minimum, which is minus 19.3. Good, so let's just a sketching again. So this is, assume this is minus 19.3. Okay, so let's go down. Okay. So in that region here, from that point to that point, V input is larger than V input minimum. Very clear, right? All these values is greater than minus 19.3. Okay, so let's draw the output in that region first. When V input is larger than V input minimum, VO is constant minus 19.3. So just draw. So this is VO here, minus 19.3. This is the zero line. So this is minus 19.3. And the VR, let's draw it with another color. Red, for example. VR is equal to V input plus 19.3. So what you're gonna do here, you're gonna add any point, any value here in V input to 19.3. So for example, at 0 here, the input is 0, so 0 plus 19.3 will give you positive 19.3. 19.3. So this, for example, the maximum, which is 155.5, you will add 19.3. So if we add 155 to 19, this will give us 174. Yeah, 174. Yeah, that's right. Okay. And we have a 0.5 and a 0.3, so 0.8. Okay, so this will give us something actually like this. 174.8. It's basically this part, for example, will be shifted up by 19.3. Okay, but still we didn't continue it because still this party. So let's do it again also. So here is 0, 0 plus 19.3, we have 19.3. And this one is minus 19.3. So when you add 19.3, it will be 0. So it's actually this portion here will just come up here, will be shifted up. Okay, so this one here, this part is actually this part, but shifted up by 19.3. Okay, good. Now let's draw or sketch the second region. Okay, so the second region actually is from here to here. So in that second region now, V input is less than V input minimum. So what's gonna happen? We are here. When V input is less than V input minimum, VR is 0. Good. So let's draw that with red. Good. So from here to here, V input is less than V input minimum, so 0. How about V out? V output is equal to V input. So good, just copy and paste. We need blue. Yes. So just copy and paste from that point to that point. Here is the values of V out of V input. I'm sorry. So here, for example, V input is minus 19.3. So we have here 19.3. Here is again it's minus 19.0. So we have here minus 19.3. Here is we have minus V maximum or minus 155.5. So we will have yeah, minus 155.5. So just copy and paste this part. Just copy and paste. We didn't finish it because still this region here. So let's do it with another color. So we have 3 regions. So this region here is similar to this one. All these values is greater than the input minimum. If so, V, so we will be here. So VO is equal to constant minus 19.3. Good. So let's go back to that. So minus 19.3. And VR is equal to V input plus 19.3. So basically, you will have this portion raised up here. So it will be something like this. Here is minus 19.3 plus 19.3 will give you 0. Here is 0. Add it to 19.3, it will give you 19.3. So basically, you take this part, shift it up by 19.3. And of course, what happened in the first cycle will happen in the second cycle, third cycle, and so on and so forth. Okay, so this is VR, and this is VO. Okay, one is above the 0 line, and one is, below the 0 line. Okay, it's much different from what we were expecting of clipping. The clipping here happens, much. So actually, this is a kind of clipping. But we clip more than half a cycle. If VB is positive, we are clipping, less than half a cycle. Now we are clipping more than half a cycle. That's the difference if you make the battery positive or negative. Okay, hope you guys enjoyed such a solution, and and good luck for tomorrow.